Hello, we are now looking at question 2, and question 2 says find the integer value of this logarithmic equation that we have here, this one here. So since we're finding an integer value, meaning we're just finding a number, so I'm going to rewrite this here. So that's log 10, so that's log 1040 minus log 10 3 plus log 10 6 minus log 10 16 plus log 10 20. So we are going to use the logarithmic rules that we learned earlier, and then we'll use them to apply the same in solving this one. So we know to say the base is the same there, and then there's the subtraction sign. So this is the same as log 1040 divide by 3, like that. Then plus, we also have a subtraction sign. We'll do the same here. This is going to be log 10 6 over 16, like that. Then plus log 10 20. Then since this is addition, it simply means what's in the brackets can multiply. It simply means what's in the brackets can multiply. So we will have log 10, then we can have that, then say 40 over 3 times 6 over 16, like that. Then we say plus log 10 20. Would have added the 20, but I just want us to move step by step. If we want, would have said multiplied by 20 so that we just resolve, but it's best we move step by step. Okay, so with this now, we know that the 3 can cancel out. 3, then divide by 3 there, which gives us 2, right? Then we can divide 2 there to give us 1, and 2 here to give us 8. Then 8 can divide into 40 5 times. So 8 there, 1, then 8 into 40, 5. So this then simplifies to log 10 5 plus log 10 20. Then this also we have log 10 100, like that, because 5 times 20, or let's just follow it step by step so that no one is left behind. So this is same as log 10 5 times 20, like this, and then this then equals log 10 100, right? Which we can also rewrite as log 10 raised to the power 2. This is the same as 2 log 10 like that, which is simply equal to 2. Yeah, which is simply equal to 2, like that. So that's our answer for that. We can quickly move to B. So B says rewrite the following as a single logarithm. So we can start with our 1. So this is log x plus log x squared plus log x squared y plus 3 log y, like that. So we then have log x plus log x squared y plus log y to the power 3, like that, right? So remember, you need to remember that we are simply applying logarithmic rules. So we know that the base here is the same for all of them. So we can simply say log x, we can simply say, so this is log there. So here the x can multiply with what's in the brackets there, with what's in the brackets here, so that we have log x to the power 3y plus log y raised to the power 3. This also we can then write as log, so the y can multiply with what's inside there, so this will be x power 3 y to the power 4, like that. So we have written this as a single logarithm, like that. So that's for part B1. We can also write for part 2. So let's just use a fresh page. So for part 2, we have 3 over 2 log 2 x minus y, like that. So basically the concepts are the same, nothing is changing. We are using the same concept. Yeah. So that, and this is minus 2 log 2, that is log log 2 x squared plus y squared, like that. Okay, so for this one we know that this will then become log 2 x minus y raised to the power 3 over 2, like that. Then minus log 2 x squared plus y squared raised to the power 2, like that. And then this, since the bases are the same, and so we know that we can write this as log 2. Then we can have these big square brackets and say x minus y 3 over 2 over x squared plus y squared, like that, then squared. We can write it like that. Okay, so this is our single logarithmic equation. So that's for question 2. And then question 3, we have that. So I think let's write it on a clean page as well. So we have log AP plus lambda. This is a Greek symbol, lambda log AP, sorry, Q, lambda log AQ minus mu log A. So the concept is the same, regardless of what symbols they choose to use to represent the logarithmic equations. The concept is basically the same. So that's log A R there, like that. So simplifying this, so this is log A P plus log AQ, like that. This will be raised to the power lambda minus log A R raised to the power mu, like that. And then since this is positive, it simply means the logarithms will multiply, or these will multiply, Q and P and Q will multiply. This will be log A PQ lambda, like that. Then minus log A R to the power mu. And then since that's subtraction sign, so we need to divide. So this will then be log A. So this will be P Q raised to the power lambda over R mu, like that. So that's how our single logarithm is going to look like. Okay, so we are done with question 2, part A and B. We will go on to part C in the other lecture. Thank you very much for watching.